Assalamu alaikum dear students. Today we are going to discuss 2's complement form, and as you can see that in your syllabus the topic is mentioned with the objective to let the students express a positive or negative number using the 2's complement form. So the 2's complement form actually it is actually the representation of an integer value into the memory, and you know that the computers, they store the numbers into the memory, and especially uh, what we learned up till now is were all unsigned numbers. And while storing these unsigned numbers, there is no issue. You only have to understand or consider the memory and the number of bits it will take to store them. However, in many cases, there is a need of storing signed number as well. And to handle those situations where we have to assign a sign with a number, we actually have to see this method or this form. So it is something where a sign integer is to be represented, and for doing this we use the 2's complement form method. So for converting a number and for using the 2's complement form, we will look into the method of a conversion of a number. Let's say we have a number, and that is 0. We have a number like we have 0, and we have 1 0 1 1 0 1 1. So for example, we have this number, and we want the method we normally use to now what we normally do while converting this number, we actually take this number, and we have 1 2 4 8 16 32 64 and 128. So we have the number like this, and just turning on the number with ones, we will get the number out of it. So we have 64, so plus we have 16 plus 8 plus 2 plus 1. So it gives us, so this is 10 26 26 and 30 90 91. So we get 91 from here. So this was the method we used to convert a binary number into a denary number. And you have seen that here we have 8 places, 8 bits, which are responsible for holding the ones and zeros, and we normally convert the binary and the denary number, and we convert a binary number into denary with base 10. So this was the case with unsigned number. So we usually do this thing for unsigned numbers. Now when we have to deal with the negative numbers, again what we will do, so in order, if for example we have minus 91, okay, so what we will do for minus 91 to represent a number in negative form. So here this is actually an example of unsigned, this is actually, sorry, a signed number. This is an example of signed number. And we have to now represent a signed number using, so for this we use 2's complement method. we use 2's complement method. For representing a 2's complement and for representing a negative number, we will have, like, we have the powers 1, 2, 4, 8, 16, 32, 64, 28. So these are actually your position 0, 1, 2, 3, 4, 5, 6 and 7. So these are your bit position. And for dealing with the negative number, what important thing we do is that we use this 7th position and we use this 7th bit, which is the most significant bit, and you also should know that this is the most significant bit and which has more value, and this is the least significant bit and it has less value. So on the most significant bit, we reserve this 8th bit for signed number. So we use it for signed values. So the bit here will represent the sign. So it means we can change it like this. So the number, this 7th number will be minus 128 in place of plus 128. So while working with the negative numbers, what we do, we take the most significant bit in a byte, and you know this is 8 bit, means it is 1 byte. So in 1 byte, the 8th bit, the most significant bit, which is the 7th bit, it will have the value in negative. It will be used for showing the negative number, for showing the sign. So when we have positive, there is no issue, but especially when we have a negative number, this sign will be on. So it will be used for showing the negative number. Now representing the negative number, we have 3 methods. The first method is that we use the same number, let's say 1 minus 128 here, and then we will start filling the values in the other, so that we will be minus deducting, so that we reach to minus 91. So we have 128 minus 128, and then if we plus, we have to see how much it will reduce. If we add 64, definitely the number will become 64, which is not which is less than the 91. So we'll not use it, we'll just leave it. Then we'll move to 32, and if we add 32 into it, minus 128 plus 32, so it will become, so we will add 32 here, so it will give us, the result is minus 96. So minus 96 means we are still a few digits behind minus 91. So we'll use it as 1. Let me also correct it. So we also have to declare this as 1. Okay, now from 19 minus 96, we have to reach, we still have 5 digits to remove from here. So we'll not use 16, we will not use 8, and we will use 4. Yes, because removing 4 will give us, so this will be minus 92. So still we have to remove 1 more digit from here. So we'll leave this and we will use this one, and hence we will add this 1 here. So we will reach to minus 91. So the result is minus 91. This is one method. This is one method. There are different methods of doing 2's complement, and I have just shown you only one method through which we will convert. So now we can say the number is of minus 91 will be represented like 1 0 1 0 0 1 0 1. So this is the number minus 91, and in this number you can see that 8 bits. We have 8 bits, 1 2 3 4 5 6 7 8, and this 8 bit, the most significant bit is 1. In all negative numbers, you should know that the most significant bit, the 7th or the 8th bit, should always be 1. This shows that this is a negative number. So this is the first method in which we have just used the most significant bit, and we started subtracting only the bit which will lead us to the number which we want to represent in it, and leaving all the numbers which will not give us the calculation, or the sum of those numbers will not give us the final number which we actually want to represent in it. So this is the first method. Now we'll move toward the second method. Okay, now talking about the second method, that is in the second method we will see there are many ways through which we convert the numbers and we represent a negative number, and the second method is, I will show you the second method. In the second method, we will take a number minus 76. Now in this second method of 2's complement, we have two steps. Number one is that we will just assume that we will not consider it as a negative number. We will just assume it is 76. So for 76, we will first convert it, and we have 64. The representation of 76 is like 64, and then we have 8. 64 and 8 is 72. No, 72 it is, and then we have 72 plus 4, 76. So we have like this. So this is the number. We'll turn all the bits off. So 76, first step is, in the first step we'll just represent a number. So as we have here 0 1 0 0 1 1 0 0. So this is the number in Denvry. So the first step is that we will take 1's complement of the whole number. So what is 1's complement? 1's complement means we will invert all the numbers. So by inverting it, it means the 1's will be converted to 0, 0's will be converted to 1, and 1 will be converted to 0. So you can see I'm just inverting the whole number. So the number will become like this. This is 0 and this is 1. So this is the first step we did. So we just have taken the reverse. We have inverted the numbers, and the number is now inverted, and it will look like this: 1 0 1 1 0 0 1 1. This is first step. And what is the second step? The second step is that we have to add 1 into it. Now what we will do, we will add 1 into it. So when we will add 1 into it, we'll do binary addition. So 1 1 is, it is 2. 1 1 is 2, and we represent 2 as 1 0. 1 1 is 2. So you know that in binary we cannot write 2. We can only represent 1 or 0. So for 2 in 2 bits, it will be like 1 and 0. So what we will do, 0 here and 1 is carried. So 1 is carried. 1 will be carry. 1 1 is again 0 1. So 1 0 here, 1 carry. So it will 1 and then all numbers same, 1 1 0 1. So this is the number of this is the representation of minus 76. This is minus 76. Now if we want to check the same with the first method, you will come to know that the output is correct. So we have minus 128. So we have plus 32, and then we have plus 16, and then we have plus 4. So it will give us minus 76 as well. So it means what will be the number if we do like this, 1 and then 0, then 32 is on, 1, 16 is on, 8 is off, 4 is on, and all other off. If we see from that method, we will also see 1 0 1 0 1 1 0 1 double 0. So you can see if you check it with the first method as well, the answer is same. So that is 1 0 1 1 0 1 double 0. So the second method output and the answer is same with the first method, which we, so this is a cross check. Okay, now talking about the third method, and in the third method it is more easiest method and it is the simplest method. For example, we take a number like we have minus 89. So we have, for example, if we do, first we will take it as a positive number 64, and then this is 4 2 6 and 6 3, no, so we'll not take it. So we'll take this one. So this is 80, 64 and 60, 16 is 80, and then we have 88, and then we have 89. So all other 0. So what we do here is that in the first method, we first convert it into a binary number, and that is 0 1 0 1 1 0 0 1. So this is a number and this is the representation of 89 in binary. Now what this direct method says, it says that you have to first locate the first one from the right side. So here in the right side we have, this is the first one. So you will leave first one, and after leaving this one, all the remaining bits will be inverted. So it will become 1 1 0 0 1 0 1. So this is the direct method. Now this is actually, and you can see it is a signed number. It is now the direct represent. So it is the minus 89. So it is the representation of this number. So this is the direct method. So boys, you have seen that there are three methods through which we can convert or we can represent a negative number, and these three methods are well explained. And in the first method you have seen that by using the most significant bit, and that is minus 128, and then subtracting or adding the positive numbers, all other digits, to reach to the digit which we want to represent. And in the second method you have seen that the first complement and the second complement, first you have to invert the number, and in the second you have to add 1. And third method, which was simple, in which which is also called the direct method, and it's the easiest method. And from the right side you will reach to the first one, and after that one you will reverse all the others numbers. And now you can see that the numbers, when we see them, the Danry numbers, like we have the positive number +7, 6, +5, 4, 3, 2, 1 up till here. You can see if we represent them in 4 bits, so you can see they are all starting from zeros, and there is no the most significant bit is not 1, they are all zeros. And when we start moving toward the negative numbers, you can see the most significant bit in these 4-bit representation, they all have ones in them. So this is the simplest or direct way of recognizing a number, a binary number, that either it is a positive number or it is negative number. Okay, there is one more point which I would like to add in the end, is that if we take these numbers, and like I will show you, if we take for example this minus, take this most significant bit as a negative number, so we can have the different representation. We can have different representation of different numbers. Like if we turn on all ones, all other bits, positive bits, as 1, and if we leave this as 0, so which number we will reach by doing this? We will this will give us so it is actually this will give us 127. This is the largest positive number if we see here. So and if we do one more thing, if we do with it, if now we turn on all the numbers, all digit as ones, what we will get from here, if all the numbers are turned on, it means what we are doing -128, and what we are doing -128 and plus, you know, the combination of 64, 32, 16, 8, all these numbers, they give us 127. So what is the result of it is -1. This is the biggest negative number. So we reach to a biggest negative numbers with it, if we do this. And the third case is that if we turn on the first digit, I will show you. If now we turn on the first digit and turn off all the other digits, if we do this, then which number we will get here is all other digits are off. It gives us the smallest negative number. Okay, this is the smallest. Negative number. Okay, and so we got 3 numbers, -1, -127, and then we got 127 as well. So these are the representation of different numbers in 2's complement method. Okay boys, now you can pause my video and you can solve these questions for practicing your 2's complement form. And I have given these few questions over here with a variety of positive and negative numbers, and some in Danry form and the others in binary form. You can convert them using all these 3 methods, and you can practice them, and I'm sure that with the help of this work you will be able to understand the 2's complement form. So boys, so these are the answers. I'm sure that you have attempted these questions, and you can see the answers of the given questions here. and from here you can get the very clear idea about the 2's complement, and dealing with binary numbers, dealing with the Danry number, positive and negative numbers, and using different methods. And this is the first learned method which I have told you in the start of my lesson. I'm sure, boys, you have learned the concept of 2's complement very clearly, and keep watching my videos. Thank you very much. Shukriya.